Hi guys, so today we will learn about integration of trigonometric function. Okay, so in this integration of trigonometric function, we have 5 types of trigo. So the first one is power of sine is odd, power of cosine is odd, power of sine and cosine both even, power of tangent is odd, and lastly is power of secant is even. Okay, this is the example from YouTube. So you can see here.
Okay, in this video I'm going to start talking about trigonometric integrals. And this is going to be part 1 of at least 6. And just because there's a lot of cases to go through. The basic idea with trigonometric integrals is you're just using trig identities and u substitution. It's nothing really deeper than that. Although sometimes making things work out, it's basically when things don't fit the correct cases when you have to be really clever. Otherwise, it's just kind of memorizing some recipes. So the first one we're going to look at is when you have cosine to a power times sine to a power. We want the powers to be positive whole numbers, and we want at least one of the powers to be odd. The idea is whoever's odd, we're going to save one of those and then use this trig identity. So I always remember the old saying, at least I always heard it was the odd man out. You're the odd man out. So in this problem, notice we have an odd power of sine. So what I'm going to do is I'm going to bust up my sine as sine squared. And then I keep a sine factor. Okay, so I'm kind of busting up again the odd guy. So again, if you multiply sine squared times sine of x, you would get your sine cubed back. Well, my cosine squared is still just hanging out in there. And now the idea is you use your trig identity, sine squared plus cosine squared equals 1, and we're going to use that to replace the sine squared term. So we would get that sine squared is equivalent to 1 minus cosine squared of x. Okay, so again, just using our trig identity, sine squared plus cosine squared equals 1. So if we solve that simply for sine squared, we'll get 1 minus cosine squared. So there he is, just hanging out. And then, okay, so there's my original cosine squared, there's my sine x, still hanging out. The whole point of doing this is now you can do a u substitution. You can do a u substitution where you let simply u equal cosine of x. Well, the derivative of cosine is negative sine of x. So multiply both sides, we'll get negative du is positive sine x dx. And then it's just a matter of replacing everything with your u substitution. So I assume if you're seeing trig integrals, you've probably seen u substitution a fair amount at this point. So we're left with 1 minus u squared. Again, cosine is u, so I'll have another u squared. And this is the whole point of saving this one odd factor, is so that your u substitution works out. So if you plug in, you'll get negative du. And now it's just a regular old polynomial that you can multiply out. So if you distribute, you'll get u squared minus u to the 4th du. If you just integrate this like normal, you'll get u to the 3rd over 3 with my negative. If I distribute, I'll get a positive u to the 5th over 5 plus c. And simply now plug your u substitution back in. So negative cosine cubed of x over 3. Whoops, cutting that off. Plus cosine to the 5th of x over 5 plus c. Okay, so that's the basic idea. So let's do...
Okay, so this is the basic idea. So
okay, in this video I'm going to start...
example. Okay, so this is the steps involving power of sine is odd. So the first step is split sine power of mx to sine power of m minus 1x and sine x. Next, you identify the sine square x is equals to 1 minus cos 2 x cos power of 2. This is identity. And substitution used is u is equals to cos x. So look at the example. Evaluate sine power of 3x dx. So split power 3 to be power 2 and power 1. And then you substitute sine square using the identity formula to be 1 minus cos power of 2x multiplied with sine x dx. Next, you let u is equals to cos x and differentiate cos x to be negative sine x dx. So you just substitute here to be 1 minus u square du negative. So integrate to be negative u plus u power of 3 over 3 plus c. So you substitute back u is equals to cos x, so negative cos x plus cos power of 3x over 3 plus c. Okay, next. So this is power of cosine is the steps. The first steps is split cos power of mx to cos power of m minus 1x and cos x. Identity used is cos power of 2x is equals to 1 minus sine power of 2x. Substitution used is u equals to sine x. Look at the example. Evaluate sine square x cos power of 3x. So you can see here power of 3 odd. So you need to split the cos only. Leave the sine. So sine power of 2x multiply with cos power of 2x multiply with cos x. So you split 3 minus 1 to be 2 and then this is cos power of x. Next, use identity cos square x is equals to 1 minus sine. So you just substitute cos power of 2x. Leave sine. So 1 minus sine square x multiply with cos x. Next, you substitute using u substitution. So sine to be u power of 2, 1 minus u power of 2. Cos x dx is du here. So you can see here is u square, 1 minus u square. So you expand. Is equals to u square minus u4 du. And then you integrate u power of 2 is equals to u power of 3 over 3 minus u power of 5 over 5 plus c power plus 1 over power plus 1. So lastly, you substitute back u is equal to sine x is equals to sine power of 3x over 3 minus sine power of 5x over 5 plus c. Right? So this is power of sine and cosine both even. So the steps involved is the first, you need to substitute sine power of 2x is equals to 1 minus cos 2x over 2 or cos power of 2x is equals to 1 plus cos 2x over 2. You need to remember this formula. Next, use the formula cos ax dx. Integrate cos ax is equals to 1 over a sine ax plus c. When you have cos, integrate to be sine. So ax you need to divide. So you need, this is the same thing. Right. So look at the example. When you have sine power of 2 3x, cos power of 2 3x. So both even. You can see here both power is even. So you can use this formula. Right. So sine power of 2 3x is equals to 1 minus cos 6x over 2. So this 3x to be 6x. This 3x to be 6x. So minus plus over 2 over 2. So over 2 you need to move out. Okay. So to be 1 over 4. So 1 minus cos 2x. 6x. So this is a minus b. This is a plus b. So it will be a square minus b square. And then you can see here there are cos power of 2 6x. So you just substitute using the formula. So you get 1 plus cos 12x over 2. So this is 1 over 2 minus cos 12x over 2. Because if you expand this to be 1 minus 1 over 2 plus cos 12x over 2. So 1 minus half to be half. So minus cos 12x over 2 du. And then you integrate 1 over 2 to be 1 over 2x minus cos to be sine 12x over 2 multiplied with 12 is equals to 24. And then you multiply with 1 over 4. So last, the answer is 1 over 8x minus sin 12x over 96 plus c. So this is power of tangent is odd. The first step is you need to split off a factor of secant x tangent x. Identity used is tangent square x is equal to secant square x minus 1. And then substitution used is u equals to secant x. Secant x. Okay. So looking at this example, we have secant x tangent power of 3x dx. So split the tangent power of 3 to be tangent power of 2x, tangent x, and then secant x just leave as a secant x. Then you know that tangent power of 2x is equal to secant square x minus 1. You substitute tangent square x is equal to secant square x minus 1. Multiply the original secant x, multiply with tangent x. Next, you let u is equal to secant x, so secant here to be u square minus 1. Secant x tangent x dx here to be du, because if you differentiate u is equal to secant x, differentiate secant to be secant x tangent x dx. So this is du. Next, you just integrate to be u cubed over 3 minus u plus c. Next, substitute back u is equal to secant, so secant power of 3x over 3 minus secant x plus c. This is secant is even. Split secant power of m x to secant power of m minus 2x and secant power of 2x. Next, identity used is secant power of 2x is equals to 1 plus tangent power of 2x. Substitution used is u equals to tangent. So look at this example. We have secant power of 4. So you need to split to be secant power of 2 and secant power of 2. Then you just substitute only 1 secant square. Because if you let u equals to tangent x, you need to differentiate tangent to be secant power of 2x. So this is secant power of 2x dx here. So they will be equals to du. So you get 1 plus u square du. And then you can integrate to be 1 is u square is u cube plus u cube over 3 plus c. So you substitute back to be tangent x plus tangent power of 3x over 3 plus c. Right, thank you.